In this lecture, we will identify the requirements necessary for a pandemic to happen. So we're going to discuss pathogens, vectors, hosts, and we'll look at several examples of each. So let's get started. Causative agents of disease may be viral, bacterial, or fungal. So, for example, you're all familiar with AIDS, the acquired immune deficiency syndrome. AIDS is caused by a virus, the human immunodeficiency virus, or HIV. Tuberculosis, on the other hand, is caused by a bacterium, Mycobacterium tuberculosis. On the other hand, pneumocystis pneumonia is caused by a fungus, Pneumocystis jirovecii. As stated earlier, many diseases that affect humans begin as infections in animals. Here's a great example. The causative agent of bubonic plague is the bacterium Yersinia pestis. It's carried by the rat flea. The bacterium blocks the digestive tract of the flea. So when the flea bites its host, that is the rat, the bacterium is regurgitated and subsequently transmitted to the rat. Yersinia pestis attacks the lymphatic system and subsequently kills the rat. After the rat dies, the flea searches out another host, preferably another rat. However, if another living rat is not available, well, any human will suffice. The human immunodeficiency virus, or HIV, is a causative agent of AIDS, and it began as the simian immunodeficiency virus, or SIV, that infected several non-human primates in West Central Africa. It is thought that humans acquired SIV after mishandling and eating infected bushmeat. Bushmeat is a staple of many peoples in Africa. As happens in these scenarios, SIV then mutated into a form that was able to evade the human immune system, and from that point it was identified as HIV. A final example of humans being impacted in a major way by an animal vector is the relatively recent bird flu outbreak. A special strain of the influenza A virus, HPAI, or highly pathogenic avian influenza virus, type A, subtype H5N1, that's a mouthful, is the causative agent of H5N1, or avian flu. Now, the virus is maintained in many bird populations, especially throughout Southeast Asia. The World Health Organization has confirmed that the pathogenicity of H5N1 continues to rise in endemic areas. And so while avian influenza outbreak has not been officially designated a pandemic, so as of October 2007, only 59 people have died from infection with no sustained person-to-person transmission. Remember, that's one of the key factors in pandemics. WHO has determined the H5N1 virus is only a couple of mutations away from causing a global pandemic. In other words, it's something that we might see in the near future. However, the bird flu situation in farmed birds, like turkeys and chickens, remains in check by the administration of vaccinations. So, what does it take to make a pandemic? Well, first we need a pathogenic organism. Pathogen is a virus, a bacterium, or a fungus that causes disease. Second, we need a vector. So a vector is an organism which carries the pathogen to another organism. Very often in nature, vectors are biting insects like fleas, ticks, and mosquitoes. Third, we need a reservoir, that is, an organism within which the pathogen can multiply. We also need a susceptible human, in other words, a person in which the pathogen can evade immune defenses. Usually, but and not in all cases, as we'll see, that will be a small child, for instance, or an elderly person who either has an underdeveloped or a very weakened immune system to begin with. And finally, we need usually direct human-to-human contact, or at least very close contact, as in the case of a respiratory pandemic like tuberculosis. Now, if all the above factors are in place, then we have the conditions necessary for a pandemic. So in the next lecture, we're going to analyze some historic pandemics, including Spanish flu, smallpox, tuberculosis, and the more recent AIDS pandemic. See you in Lecture 5.